So in the previous video, we did define what is a fluid, and we agreed that fluids is the combination of liquids and gases. And the reason of excluding solids out of it is the limitation of the applied force that came into the definition of a fluid that results in a continuous deformation of the material. And that's the reason why we only pick the liquids and gases here. Before we continue talking about the fluid mechanics, let's talk about the force, deformation force. I would like to give a little bit of description about the deformation force. This is maybe takes you back to statics or dynamic courses here. So if you have a body, and let's assume that body is fixed here, then you apply a force in this direction or force in this direction. This type of forces, we call that actually the normal force. And the normal force usually may lead to a compression in your material or do stretching to your material. And later on, when you study more strengths of material, you will understand that normal force usually leads to normal stress. Normal stress. And the definition of a stress is simply the force over the area that you apply that force. So it's stress usually takes sigma, right? That's the stress, and you define the force, you divide force over area, that give you sigma here. So usually the first type of deformation forces is normal force, right? Which causing either stretching, we call that actually elongation of your material, or maybe compression. And when you divide that force over the area applied over, you'll get what you call it normal stress. So this is going to be a normal stress because it's coming from normal force applied over a specific area, right? The second common type of deformation forces is when your body is exposed to, this is fixed, I'm applying force, and that force is really parallel to that surface. Imagine this is the 3-dimension top face here, and you are applying that force that's fixed as well. So now this force applied to that face or that area here, this is the area, is they are now in not normal position, they are parallel position, right? So we call that type of forces is number 2, we call that actually shear force. Let's actually remove this. So shear force is an applied force that's parallel to the applied surface area. Okay. So shear stress or shear force will result into a formation of shear stress. And shear stress is the same as the applied force over the area, and shear stress take the symbol tau and the force divided by area. So the difference between the normal stress that will result in deformation by compression or expansion or stretching, that's a normal stress, while tau is a shear stress, will lead to a deformation. The difference between the cases is the relationship between the force and this area. In the normal stress case, the force and area are perpendicular, while in the shear stress case, the force area are parallel to each other. And this is just give you some idea about the different forces here. So when you go back to the original definition of a fluid, let me write down in a different color here. I will write down that in maybe a green one. So if you go back to the definition of fluid, we said it's the fluids are materials deforms continuously under the action of. Now when you read carefully in your fluid mechanics books, you will find the word shear. Go back to the green. Force of any value or magnitude. Now all what I did now, I added a new word to the definition. I didn't want to mention that in my previous video because I don't want to you get confused about the word shear. So we talked about the deformation force. Now we understand what is meant by the word shear force, and this is why the reason I explained that part here, to understand shear force is the force that's responsible for deforming the fluid material continuously, regardless of the magnitude of that force. And this is just an additional part to add to the definition of fluid mechanics. Now I'm going to move to the definition of the second part of the title of the course, which is mechanics. What is mechanics? Let me meet you in the next video here.